In our next section, we will have a look how to configure a Dmvpn. So this example on the screen is showing a topology used to explain Dmvpn configuration and functions. We have router 11, which is the Dmvpn hub, and we have router 31 as the Dmvpn spoke, and router 41 that is the Dmvpn spoke. All three routers use a static default route to the service provider router that provides connectivity for the MBMA networks in the 162.16.00/16 network range. And also EIGRP has been configured to operate on the Dmvpn tunnel and to advertise the local LAN networks with care to prevent recursive routing. But our main focus in here, guys, are how we can configure the Dmvpn hubs and what we need to do on the Dmvpn spoke side. So on the hub config, let's start with the hub config. So on router 11, we are defining a tunnel interface and interface tunnel 100. And please check the tunnel name is set to same for the spokes as well. And also we are defining a bandwidth in here with bandwidth and 4000. So defining a bandwidth value is actually optional for Dmvpn configuration, guys. Virtual interfaces do not have the concept of latency and need to have a reference bandwidth configured so that routing protocols that use bandwidth for best path calculation can make an intelligent decision. Bandwidth is also used for QoS configuration on the interface, and bandwidth is defined with the interface parameter command with bandwidth in here you can see. Then we are assigning an IP address to our tunnel interface, and this is 100.11. Okay, this is gonna be our tunnel interface configured for the hub. Then we are modifying the MTU. We have talked about this one, why we are modifying the MTU and the MSS values in here. Then guys, we can define an NHRP network ID in here, which is set to 100 in this case. So enabling NHRP and uniquely identify the Dmvpn tunnel for the virtual interface with the interface parameter command IP NHRP and network ID. The NHRP network ID is locally significant, and it is used to identify a Dmvpn cloud on a router because multiple tunnel interfaces can belong to the same Dmvpn cloud. It is recommended that the NHRP network ID match on all routers participating in the same Dmvpn network. And you can also see that in here we have a command IP NHRP map multicast dynamic. Guys, NHRP, this is optional also. And please also keep in mind that this configuration is for Dmvpn phase 1 hub. Okay. Guys, NHRP provides a mapping service of the protocol tunnel IP address to the MBMA transport address for multicast packets too. In order to support multicast or routing protocols that use multicast, this must be enabled on Dmvpn hub routers with the tunnel command IP NHRP map multicast dynamic. Okay, then in here we are defining a tunnel source as tunnel source gigabit Ethernet 0/1. The tunnel source depends on the transport type, guys, and the encapsulating interface can be a logical interface such as a loopback or a sub interface also. Then guys, we are converting the tunnel to a GRE multipoint interface. So The command is tunnel mode GRE multipoint. And in here we have another optional parameter, which is the tunnel key. Tunnel key is set to 100 in here. So this key should match for both hub and spoke routers to establish a tunnel between each other. Let's talk about the spoke configuration now. Configuration, guys, on the spokes is similar to the configuration for a hub, except one, it does not use a multi-point GRE tunnel. Instead, the tunnel destination is specified. That is the first difference. And second difference on the spokes is the NHRP mapping points to at least one active NHS. So we can check the spoke configuration also in here. So interface tunnel 100, that's the same with hub, and we are setting the same bandwidth. So IP address is surely changing. MTU is set to same value. So these are almost same. This is the similar thing, surely. And MTU and the MSS is also same. Okay. Network ID is also same. Tunnel source is, the similar logic. Tunnel destination, we don't have this one on the hub, right? And tunnel key is also same. So only difference that we can see in hub and the spoke is just we are defining a tunnel destination for the Dmvpn spoke. This is the IP address of MBMA, I mean the transport IP of the hub, which is 11.1, you can see in here. And also, we are using the command IP NHRP NHS, that is the hub, and the 100.11, which is the IP address of the tunnel interface of the router 11, and MBMA 11.1, and the command is finishing with the multicast option. Okay, this configuration is almost same for the other spoke also, but just some IP addresses are changing. So let's check how we can verify Dmvpn phase 1. So the command is show Dmvpn. That's the really basic command that we can use for both spoke and the hubs. When we check the show Dmvpn output for router 11, we can see that we have two pairs. And these are our NHRP peers, and here are the peer MBMA addresses. And here is the peer tunnel addresses, and they are .31 and .41 as we configured. And state is up for these Dmvpn tunnels, and attribute is D, that means dynamic. When we check the output for these spokes, let's check for rather 31. When we type show Dmvpn, it's showing the type as spoke. Please check also for hub that is showing type as hub. And we have just one NHRP peers now. Okay, and that is the hub. And here is the hub's peer MBMA address. And peer tunnel address is .11 for both. And we can see that state is up and attribute is S for this time, which is static. Okay, everything is looking great now. and output is looking correct. This is how we configured the hubs and the spokes already. We can also check the show Dmvpn detail, and this command provides the tunnel interface, tunnel role, tunnel state, and the tunnel peers with uptime. So it's giving some more detail. So interface is tunnel 100 and it's on upstate. Here is the address for this one and some more detailed information as well. So to verify the Dmvpn phase 1, we may also view the NHRP cache. The information that NHRP provides is a vital component of the operation of Dmvpn, and every router maintains a cache of requests that it receives or is processing. The command show IP NHRP displays the local NHRP cache on router. Router 11 contains only dynamic registrations for router 31 and router 41. In the event that router 31 and router 41 cannot maintain connectivity to router 11's transport IP address, eventually the tunnel mapping will be removed on router 11. The NHRP message flags on router 11 indicate that router 31 and router 41 successfully registered with the unique registration to router 11, and that traffic has recently been forwarded to both routers. So when we check the router 11, which is the hub, show IP NHRP, which is showing the NHRP cache, we can see the information for router 31 and router 41. And when we check the NHRP cache for the spokes, we will just see the information for the hub router, which is router 11. You can see in here. And please keep in mind that the type is dynamic for a hub and the type is static for the spokes again. So that is the verification also. So this screen is providing the output for the show IP NHRP brief command this time, guys. Some information such as the used and next hop NHRP message flags are not shown with the brief keyword. So now let's check the routing table of the hub. Okay, we configured the Dmvpn phase 1 and everything is looking fine. We verified the tunnel is up, but how the routing table is looking. So on router 11, which is the hub, when we type the show IP route command, you can see in here we have networks for 10330, which is the local area network segment of router 31, and 10440, which is the local area network segment of router 41. And we can see that how we how this hub learned these routes is via the 100.31 and 100.41, which is the tunnel interface for the router 31 and router 41. So when it comes to the routing table of spokes, and if we were to run the show IP route for both spokes, we can see that here is a 110 network for 31. 110 is the local area network segment of router 11. So it is learned via router 11's tunnel interface. And we also have 10440, which is the local area network segment of router 41. And this is also learned via the hub tunnel interface. You can see in here we are learning it also from 100.11 because this is the Dmvpn phase 1 and there is no direct communication between the spokes. So if you were to check the trace route on the SPOC, on router 31, trace route 10441, and we can see that traffic is going to the hub's tunnel interface first, then it's just reaching the SPOC 41. So now let's check the configuration of Dmvpn phase 3. The phase 3 Dmvpn, guys, configuration for the hub router adds the interface parameter, the command IP NHRP redirect, as you can see in here. This command checks the flow of packets on the tunnel interface and sends a redirect message to the source SPOC router when it detects packets hairpinning out of the Dmvpn cloud. Hairpinning is when traffic is received and sent out of an interface in the same cloud. For instance, packets coming in and going out of the same tunnel interface is a case of hairpinning. And the phase 3 Dmvpn configuration for SPOC routers uses the multi-point GRE tunnel interface and uses the command, and you can see in here, IP NHRP shortcut on the tunnel interface, which enables the NHRP shortcut function. Please notice that all three routers have tunnel mode this time, GRE multipoint, tunnel mode GRE multipoint, and tunnel mode GRE multipoint. And the other configuration is just same with the Dmvpn phase 1. So let's check how a trace route is looking like from the router 31, which is the SPOC's point of view. If we trace route to 10441 for router 31, we can see that firstly the packet is going through the hub and then reaching the SPOC. So this is the initial packet flow, guys. After SPOC to SPOC tunnel is established, which is the main advantage of the Dmvpn phase 3, and if we were to trace route towards the same IP again, we will just see one hop, and that is just the 100.41 IP address of the router 41. After a SPOC to SPOC tunnel is established, we can verify Dmvpn status again. So in this output, there are two new SPOC to SPOC tunnels, guys, and they are highlighted in here. You can see these are the SPOC to SPOC tunnels, and this entry with attribute DLX represent the local, which is no socket routes, and the original tunnel to router 11 remains as the static one, as you can see in here. So when we type the show Dmvpn detail for router 31, we can see this output easily. So we can also check the NHRP cache again, and the output on the screen displays the NHRP cache, and notice that the NHRP mappings are router, RIP, NHO, and the nhop, which is the next hop, and the flag RIP NHO indicates that the router has found an identical route in the routing table that belongs to a different protocol. NHRP has overridden the other protocol's next hop entry for the network by installing a next hop shortcut in the routing table. The flag RIP nhop indicates that the router has an explicit method to reach the tunnel IP address via an MBMA address and has an associated route installed in the routing table.